Hello, this is W.Theiss. Before I talk to you about one of my products, I would like to introduce myself. A very long time ago, I studied physics at Aachen Technical University and Northeastern University in Boston. During my university work, I did a diploma thesis about statistical physics, very theoretical, and then I tried to be a little bit more practical, working for an institute doing optical spectroscopy in the infrared. And there my task was to develop methods that would help us to understand what we measure. During this time, I handled a lot of inhomogeneous materials, trying to understand their optical properties. And also during my habilitation time, I worked with an inhomogeneous materials, namely porous silicon. During my university work, I started to develop computer programs that would do what's called optical modeling. That means you start at the basic level of material properties and layer stacks, and you produce simulated spectra that you can directly compare to measured spectra. And this way, we try to understand and extract information from optical spectra. Then, after a while at the university, I decided to create my own little company, developing software initially. And here are my software products. The main product, basically the basis for all the others, is called Scout. And Scout is used by most of my customers for thin film analysis. That means you extract information from measured spectra concerning layer thickness values or optical constants, or both at the same time. One more feature is contained in code. Code can do everything that Scout can do, but in addition, it offers some design features in the sense that you can optimize the coating concerning materials and layer thicknesses so that the technical performance of a coating product is best. There's an add-on to code which is called genetic code. Genetic code is using an evolutionary algorithm or a genetic algorithm for doing automatic thin film design. Basically, genetic code can tell you what materials you should use in your stack and how thick the layers should be. And basically, the only thing you have to do is to write down the problem carefully. Once you have a coating product, you can use my Brain software to do optical production control. Brain picks up measured spectra that you record somewhere in your production at certain positions where you have partial layer stacks or the complete layer stack, and Brain does a sequence of automatic fitting procedures in order to extract as much information about the coating as possible and give feedback to the operators about what they produce at the moment. Many of my customers develop coatings for architectural glass, and they use sometimes the marketing software SCORE. SCORE can predict the properties of glazing products. That means coated glass paints with foils in between or gas fillings in between. So a complete glazing product can be defined in SCORE in a very simple way, and then you can predict what optical and other technical properties this product will have. The spray software has been introduced to solve problems where light rays are distributed in space in a more or less unpredictable way. You've basically used the software to follow light rays from the light source through a scenery, and you record where is how much radiation going. In many training courses, I realized that many of my customers did not get a real education in optics. Nevertheless, they are expected to solve thin film problems or to optimize coatings. So I thought it would be a good idea to have a very short, comprehensive, interactive optics course that you can use at your own speed. And I generated the Visual Optics program, which is a Windows program that lets you interactively learn what you should know about coating properties and material properties. Okay, besides pure software development, I also develop hardware components, basically probe heads for measuring reflectance and transmittance at more or less arbitrary angles of incidence. I build integrating spheres with special ports which are useful for the investigation of textured glass for solar cells or textured silicon wafers also for solar cells. The light sources that I use are also developed by myself, and most of the parts that I use in my components are realized by 3D printing, which makes them rather cheap and easy to be produced by a small company, actually a one-man company like mine. In addition to software and hardware development, I do teaching and training, and I support customers as a consultant in optical problems.